Hello, welcome to my channel. My name is Laurent. In this video, we're going to deal with vector addition. Good. So this is a video devoted to our course on vectors. Okay. So we started off with definition of vector up to length of how to find length of vectors, and then how to determine a vector given its initial point and its terminal point. So if you haven't watched those, I would advise you go back there. But of course, if you've gotten those basic skills or ideas already, then we can just go on right away, right? And don't forget to subscribe to my channel if you find my video helpful and share with your friends. Good. Okay, so let's simply get what vector addition is all about, or what it entails. Okay, now first of all, vector addition is just, in this case, we're going to consider the sum of two vectors, and I should tell you that the sum of two vectors is again a vector. So for a definition, I would say given two vectors, let's say the vectors are vector u and v. Okay, then we have that the sum, then the vector, which is given by the sum of these two vectors, u plus v, okay, can be gotten from this. Okay, so to determine the sum of two vectors, we have to place the initial point of the second vector on the terminal point of the first vector. And in fact, we could also do it in a different order. We could place the initial point of the first vector on the terminal point of the second vector, and that is so because vector addition is commutative, so the order is irrelevant, right? So let's just illustrate what we are saying right here. So let's say this is vector u. It's pointing in this direction, which means this is its terminal, this is its initial point, and this is the terminal point. Let's say we have vector v like this. Okay, let's say it's a little more, it's a little less steep, pointing in that direction. So you want to find out what the sum of these two vectors will be. Okay, so let's say the sum will now be, so I'm going to say we should place, for us to find u plus v, that's vector u plus vector v, if this is u, I didn't label them accordingly, so this is vector u, then this is vector v, right? To find u plus v from this definition, we say we should place the initial point of vector v on the terminal point of vector u. So this is vector u. Okay, let me make the line nice enough. So this is vector u. Okay, it ends here. Do we want to place this, the initial point of this vector, which is this, on the terminal point of the first vector, which was vector u. So to do that, we'll just place the initial point of this vector, this, okay, on that, then put it up there. So we should try to maintain the slope. Of course, we are doing it freehand, so it wouldn't really be as it should be, but at least the idea should be gotten. Okay, so this is what I'm saying. Place the initial point of vector v on the terminal point of vector u. Again, we dealt with that in a previous video, so please do well to watch that. So this is how to think about addition now. For vector u, we started from here up to here. Therefore, vector v, we started from here to there. That means the sum will take us from this point to this end point. So it's just the straight destination, the displacement will just be just the sum of those two vectors, right? That's the displacement. So let me use a different ink so that you could easily get the idea. Okay, great. So that means this right here is u, vector u plus vector v. That's the sum of these two vectors starting from here to there, so you could just get that. Okay, great. Now you could say, so what if we decided to switch order? What if we put vector v first before vector u? Will it still make sense? Of course, like I said, vector addition is commutative, so regardless of the order. So let's say these are the vectors u and v, then you want to place vector v first. From this definition, that means you're going to have to modify a little bit by putting the initial point of vector u on the terminal point of vector v. So this is it. We're going to have vector v first. Sorry, we're going to have vector v first before vector u. Okay, so look at vector v. That's how it was. So it's this way. So when then we're going to put the initial point of vector u will be on the terminal point of vector v. Now this is the terminal point of vector v, this is vector u, so going in that direction, the initial point should be on the terminal point of v, then go like that, just in the direction of vector u as it was, and then we have that to be the vector u. So what is our resultant vector? The resulting vector is a vector going in this direction, which is that from here down to this point, right? Good. Now if you look at the two diagrams, this and that, you would see that the direction and then the size, of course, in my diagram I haven't really taken care of the size, I'm just making it kind of random, but you can see the direction makes sense. And all that matters when it comes to vectors is their direction and their magnitudes. So neglecting the magnitude here a little bit because I'm just doing this freehand, you can see that the directions make sense. Okay, so the position of the vectors is immaterial. All that matters is the size of the vector and then the direction of the vector. So as you can see, they both have the same direction and possibly the same size. So that means that this u plus v is something as vector v plus u, which means vector addition is commutative. Okay. We'll still verify that as we proceed, but for now let's just get right into some examples. So let me put down examples right here. Okay, so we'll get some examples to help us know how to actually add two vectors if we are given. So let's say we have the following examples. We have to want to find the sum of these two vectors, vector u plus v, if we are given that vector u is a vector containing 2 and -3, 2 in the I direction and then -3 in the j hat direction, and then we're given vector v to be a vector pointing or to be a vector containing -1 in the I hat direction and then 5 in the j hat direction. And of course, I should show you a different notation of representing vectors. So let's say you don't want to use this notation. This is how to also write it. 2 in the I hat direction, so you put 2 with unit vector I. That is to say, you multiply the magnitude with the direction, or with the unit vector pointing the direction of that vector. Then we now have plus, this is -3, so say plus -3, right? That's just like say -3, but this is pointing in the the first one was in the I direction. Yeah, so this is pointing in the I direction, I hat, while this one is in the j hat direction, which you could simply just evaluate the positive times minus, which will give us a minus out there. Then for this one, we can say -1 in the I hat direction, then plus 5 in the j hat direction. So these are different notations. They mean the exact same thing, but just a different way of representing. Okay, great. So let's visualize this. So I'm going to put out my axis, okay, to help with the directions. Then I'm going to need 2 on the x-axis, that's +2. So let me mark out a little. Then I'm going to need -3 on the y-axis. I'm going to need -1 on the x-axis. So I'm going to go for -3, 1, 2, 3. That's about right. Then we're going to need 5 on the y-axis. So you say 1 to 5. So you just pick something like that. Good. Okay. So let's get the vector u first. Okay. Vector u, that's 2, -3. I'm going to go over there to look for 2 on the x-axis and then -3 on the y-axis. So it's somewhere here. Okay. Let me make it better. So it's somewhere there, and of course we know the drill. We just this means the position vector, right? So position vector from the origin down to this point where we are given. So down to that. Good. That's vector u. That's vector u. Then to get vector v, well, we could simply just say -1 up to 5, right? Maybe let's just do that for you to. Before I use the definition we used earlier. So from there, So let's just simply put that. That's vector v. Good. So we'll have that to be our vector v. Okay, so to add these two vectors, recall that we say the addition of two vectors is done by putting, if it is in this order of u plus v, we determine that by putting the initial point of vector v on the terminal point of vector u. Good. So the initial point of vector v is here. Should be placed on the terminal point of vector u. So what we want to do now is to observe this. We observe that this vector goes this way. It moves by, that is, it reduces by -1, the size of -1 on the x-axis, as it by 5 units on the y-axis. That is to say, for every 5 units of increment in the y-axis, we have 1 unit of decrement in the x-axis. Good. So if you have to start vector v at this point on the terminal point of vector u, we're gonna go in this direction, and we're gonna make sure we move 5 units upwards. That's upwards, okay, in the y direction, and then negative or 1 unit backwards, right? So as we go upward, we move backwards. So it's something like this. So let me just try to illustrate a little bit. So as we go upwards by 5 units, which will land us at 2, from -3 plus 5, which should land us at 2, right? And then we should move backwards by 1 unit. So it should land us at 1. So that is how vector v is. Again, the position is immaterial, but the direction and the size matters. That's why you have to be careful. So let me just say it one more time, just to pick everyone along. So you see vector v, as it increases by 5 units in the y-axis, it reduces by 1 unit in the j-axis, or maybe I should stay in the I-hat direction. So starting from the terminal point of u, it's going to go up by 5 units, and as it's going up, it's going backwards by 1 unit, leaving us with something like this, leaving us with a vector that goes this way. This is where to stop. Good. So you notice that from -3, 5 units upwards will land us at 2 on the y-axis, and then from 2 reducing by 1 will land us exactly at 1 on the x-axis. So that is our vector. That's the vector that's vector v. Okay, so let me try to erase a little of this to make the work a little bit better. All right. Okay, that's not really nice. I think this is better now. Good. Okay, so given that this is u, and then this is now a vector v, the v we want, right? This is now a vector v. We want to know what the sum will be. So since u started from here, and then after adding v we end here, it means this is now a result. A resulting vector moves from the initial point of v the initial point of u up to the terminal point of vector v, and we could read that easily because it's a position vector. We could read that easily by saying this is 1 on the x-axis, that is the sum of these two vectors. We'll say vector u plus v is 1, and then we have 2. This is 2, right? So this is the vector that we've been looking out for. Okay, let's do one more example. Okay, yeah, we can observe this result and then use this to simply do another example without having to do the graph all the time, right? Okay, so let's see what we get. Now you see that this is vector u, vector v. Now the result, that is after adding them, we get 1, 2. Well, you should observe this. 2 minus 1 is 1. The -3 plus 5 is 2, right? So it seems as if we can just simply add the entries in the I direction. Okay, that is the size, the portion of the vector pointing in the I direction. We can add those together, and then the portion of the vector pointing in the j hat direction, we could add those together and then simply get it. And of course, it makes sense to think about. It makes a lot of sense to think about because we can't simply add this to that. Okay, they are in different directions. Okay, just like having a force on a body. So if you apply a force on a body in a particular direction, okay, and then you apply a force on a body in a different direction, we can't simply get the resultant force, because the resultant force will be in this direction. We can't simply get it by adding these two forces, no, but rather we need angle of inclination of these two forces, which will not give us the same result if we were to add the two forces. We can only add the two forces if the two forces were pointing in the same direction. Good. Okay, so that makes sense to think about again. Said so. All right, so what we'll simply do, instead of having to represent this and maybe try to, skillfully, like I tried to explain to you, placing the vector v in a different position to determine this, what we could simply do is to say 2 minus 1 gives us that, and then this and that will give us that. So maybe let's just use that idea to do just one more example, and you can do as many examples as possible under addition of vectors. Okay, so let's just think about this last example, and this will be in 3D. So I will say add this vector to that. So if you're given a vector 2, 1, 2, and negative 3, and then you want to add that to this vector 4, 5, and 2. Okay, so you want to add that to this vector. So what should we do? Well, recall from what I just explained, we should just add the corresponding entries. So pointing in the I hat direction, 1 and 4, we just add them together, we get 5. Pointing in the j hat direction, 2 and 5, adding them together, we get 7. And then lastly, pointing in the k hat direction, negative 3 and 2, I am adding them together, we should just get negative 1. Good. So that is the result. So maybe let's just do one more, and this should just be a matter of notation. So let's say we have to. Good. So I'm like using different notations, of course, just to make you a little bit familiarized with them if you aren't. So we have this vector, and then this is another vector. Okay, great. So don't be confused. These notations are the same. This is 1, 0, 3. So again, we could rewrite this using that as simply saying, okay, since this is pointing in the I hat direction, that's the first entry, this is pointing in the j hat direction, and then this is pointing in the k hat direction, and it's just minus 1. So we just pick the coefficient minus 1. That's how to rewrite it. Then this should simply be the coefficient of I there is 1, the coefficient of j is negative 1, and the coefficient of k is 10. Okay, so with that, we remember adding corresponding entries. So we have 1 plus 2 plus 1, that's 4. Corresponding entry 0 plus 5 minus 1, that's 4. Then lastly, 3 minus 1, that's 2. 2 plus 10, that's 12. So this is the vector we get, right? Okay, I hope that wasn't too bad for us. We've been able to do vector addition. You may ask, what about vector subtraction? Well, for us to do that, we need to first of all look at multiplication of a vector by a scalar. Okay, all right. Anyway, thanks for watching. I hope you enjoyed the video. Please don't forget to subscribe to my channel, share the video with your friends, and we'll continue from our next video.